Okay, Assalamualaikum and a very good morning. Today our group will present reinforced concrete application and a failure in construction. My name is Muhammad Azri Irwan Shah bin Ros and my group member is Edi Amiro bin Edi Asmira, Amira Fizi bin Azmi and Muhammad Afisuddin bin Muhammad Fuad.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afisuddin bin Muhammad Fuad. Matrix number 20236962232. Today I want to talk about the reinforcement concrete. The reinforcement concrete is the combination of reinforcement steel and the reinforcement and concrete. The purpose of the reinforcement concrete is to take the tensile and compression stress. So what is the application of reinforcement concrete? Basically, reinforcement concrete is very useful nowadays in construction work. For example, reinforcement concrete can be used in making the RC bridge, concrete pipe and the flyover. And the most important part is the building structure. The reinforcement concrete can be used from foundation up to the roof of the building. So for example, the reinforcement concrete can be used for foundation, can be used for slab, beam, column and wall.
I am going to present about the structure failure of reinforced concrete. The main cause of slab failure is due to the type of soil, which is a pit soil. This type of soil is easy to settle and is not suitable for buildings. In addition, the cracks also occur due to the incorrect selection of foundation, which is bad foundation. This is because the foundation does not have enough depth, which causes the soil to not withstand the load from the structure. The tremors produced by heavy vehicles will also cause the soil structure to become loose and easy to settle because the house is close to the road. For the second picture is the beam crack. This crack is due to the difference in the position caused by the selection in inappropriate foundation. Apart from that, it is also due to the design of the beam, which is not small, which causes it to be unable to withstand the load from the structure. It is also caused by the beam being exposed to the environment such as water and air, which will cause the reinforced to rust and produce rust on the beam. For the third picture is the column crack. This is because tension due to an isolated settlement of the foundation. Besides, inappropriate material and quality also can give the beam to be cracked because of the selection of steel is small.
Next, I want to talk about the concrete failure. The concrete failure basically means that the concrete lost its strength and durability to take the load that caused by a few factors. For example, number one is the improper mix design. That means the improper ratio between sand, cement and aggregates. The second one is poor material quality. The concrete made from poor aggregate quality, for example. And the next one is poor workmanship. That can lead to the improper mix design ratio and the improper compaction process. And the next one is lack of proper placing and curing procedure. The wrong curing process can lead to the concrete failure. For example, if the curing process is too cold, it will stop the curing process, and if the weather is too hot, it will make the curing process too fast. The next one is different settlement. Different settlement will affect the concrete for example, the column and foundation. And the last one is unintentional load. For example, the engineer estimate load at initial building construction is not matched with the actual load. Next is what are the type of concrete failure. The first one is honeycomb. It is the rough pit surface or voids on the concrete surface. It is happen because of the improper mixed design. It means the improper ratio between aggregate and cement. The next one is segregation. It means the separation between the ingredient in the concrete. For example, the water and cement at the top of the concrete and the aggregation at the bottom of the concrete. It is happen because the delivery time, for example, from the batching plant take so long time to reach the construction site. And the last one is crack. Crack basically the concrete crack basically have many type, but in this slide I will show the slab crack that happen due to the different settlement.
Okay, furthermore, what role does reinforcement play in preventing concrete failure, and what are the consequences of inadequate reinforcement? Firstly, its role. Number 1, tensile strength enhancement. Reinforcement increases the tensile strength of the concrete. The reinforcement is usually in the shape of steel bar or mesh. This lessens the tensile strength that build up in structures that are subject to different load. Number 2 is crack prevention. Tensile stress causes concrete to crack. Reinforcement limits the crack width and spread. It serves as a barrier, keeping the concrete from fracturing and spreading, which could affect the stability of the structure. Number 3 is improved ductility. The reinforcing make the concrete structure more ductile. The material ability to absorb energy and deform before failing make it ductile, which increase the structure resistance to dynamic load like seismic activity. And number 4 is load distribution. By distributing load more uniformly across the structure, reinforcement act to lessen concentrate area the localized stress. It's guarantee that no one part is overworked, fostering effectiveness and harmony. And secondly is consequence. Number 1 is structure weakness. The concrete structure is not strong enough to withstand force such as shearing and bending. If it's not properly reinforced, this may cause the structure as whole to have a weakness and weak place. Number 2 is limited ductility. The structure capacity to flex and absorb energy prior to failure is dismissed by inadequate reinforcing. The structure become more brittle and less able to handle dynamic load as seismic occurs as a result of its decreased ductility. Number 3 is safety risk. In the end, residents and the surrounding region are at danger for injury from insufficient reinforcing. Property damage, casualty and fatalities may arise from structure failure. And number 4 is increased maintenance costs. Building lacking sufficient strength may need expensive regular repair. In order to preserve functioning and safety, it becomes imperative to identify any crack, structural flaw or corrosion issue. Question 4 is what sign or symptom indicate potential concrete failure in a structure? Alright, the first picture is visible crack, and the second picture is rust stain. The third picture is water infiltration, and the last picture is efflorescence. There are 3 techniques to help prevent concrete failure. The first technique is slump test. This technique is to check the consistency of concrete in the field. This is also to check the correct amount of the water in the mix. For the second technique is cube test. This test is determining the compressive strength of a concrete element. This cube can be tested at 7 and 28 days because the strength of the concrete is a full strength. This technique used the compression testing machine by using the hydraulic machine. And for the third technique is proper compaction. Compaction significantly increase the ultimate strength of concrete. The formwork is fully filled by the concrete. These techniques can avoid from defects of concrete.
The next is testing method or technique available to assess the risk of concrete failure in the existing structure. The first one is destructive test, DT. Destructive tests are the method that involve physically removing or altering a portion of the structure to assess its property. Example included core sampling, compressive strength testing, pull-off test, flexural strength testing, and shear strength testing. Next one is non-destructive testing or NDT. Non-destructive testing, or better known as NDT, is a form of material or a component testing method of involving any form of destruction, damaging, or altering the structure of material. The example is radiographic testing, ultrasonic testing, magnetic testing, radiographic testing, digital ground penetrating radar or GPR. The last one is proper maintenance and repair practice help prevent or address concrete failure in structure. The first one is regular inspection or regular maintenance. Regular cleaning is essential to prevent the accumulation of dirt and grime on concrete surface. Averting discoloration and staining, sweeping and washing should be done consistently with tough stain requiring the use of a pressure washer or a specialized concrete cleaner. The second one is a protective sealing. Apply a concrete sealer periodically to safeguard against the stain, water damage, and general wear and tear. The frequency of sealing should increase for concrete exposed to heavy traffic or harsh weather condition. The last one is a crack repair. Unsightly concrete crack can lead to water seepage and further deterioration. Repairing crack involves through cleaning and filling with a concrete repair compound using a high quality TMT bar if necessary. Larger crack may require a concrete bath or a more robust repair product. That's all from us. Thank you.